Hey everyone, I'm Killian here at Sonar. We just launched Sonar Vortex, which is the guide and verify part of the agent-centric development cycle, or ACDC. The model is pretty straightforward. Guide gives an agent the project context and constraints that it needs before it writes. Verify checks its work while it's still in the loop, and solve, through the remediation agent, addresses a backlog that's already there. AI agents are able to read a repository and write code that compiles, and sometimes pass tests, but they don't always know what the architectural boundaries are that they shouldn't be crossing. They also don't know what dependencies are acceptable, and they don't know what the team isn't necessarily willing to trade away. So that's the core of what Vortex solves. Guide is about more than just context. It gives the agent the project architecture, coding and security requirements, dependency guidance, and the intended architecture. That way, the agent knows not just how the code base is put together, but what needs to stay true while it changes the code itself. It doesn't start by rummaging through a repository or taking in a giant source dump, but it can follow the relevant class hierarchy and call flows with the project rules right there for it to access. Now, good guidance helps, but models can still write code that looks good, but it actually isn't. So Vortex gives you an independent verifier. SonarQube analyzes the change while this agent still has the task context at hand and is able to fix the finding. Now, that can be one file, or when the work crosses multiple, SonarQube Vortex executes deep analysis across those files, so that includes the data flow, the control flow, and it does taint analysis. That's separate from just a lint check, because it also covers the architecture, structural concerns, and any dependency risks. In addition to this, secrets detection is a capability that's separate, but also included in this setup, and it runs before the agent uses any content, while agentic analysis runs after any edits are made. This is the agentic-centric development cycle. Guide helps the agent make a change that fits the project, then verify checks the result. Solve is offered through the SonarQube remediation agent, which works on the backlog. The CI still matters, but now the agent gets feedback for the pull request, which is where it just traditionally had to access in order to get any information back. All right, so let's hop into some code. What I have here is the Claude Code CLI, and I have the SonarQube plugin installed as well. This lives on top of the SonarQube CLI. And I've installed the hooks. All of this gets set up when you do Sonar integrate, which is a command in the plugin. One of the things that it installs is this context augmentation skill, which it uses. It makes MCP tool calls to pull in guidelines and architecture and relevant rules and things like that. One of the things I'm going to do first is give it a prompt. Actually, before that, I'm going to make sure I'm invoking the context augmentation skill. What that does is it makes sure that these tools are actually being used. And I'm going to tell it to add a public method, analyze pauses to the GCToolKit class. And kind of my reasoning behind using this prompt is I want it to be tricky enough to hopefully cause Claude to stumble up a little bit, and we can see some issues that SonarQube catches, but not too complicated that we're here all day waiting for it to run. So I'm going to go ahead and run that now. What we should see is a guidelines injection and pull those coding guidelines based on its actual SonarQube history. Things like cognitive complexity, things like that, any architecture relevant information, so that Claude shouldn't need to just go and grep through your entire source code. We want to make sure that its context is used efficiently. Things get expensive very fast. Okay, it's running all of these commands, Sonar context navigation. So it's making sure that it knows what's in the source code itself, that it's getting a good idea of the relevant architecture, parent-child hierarchy, things like that. One of the things that we found when using context augmentation is that it actually saves a lot of tokens. It saves tokens on the front end, like kind of how I just mentioned, saves it through having to search through all of your code to determine how it works, but it also saves tokens in the long run because it develops code in a more maintainable fashion. And that means that developers are saved a lot of time and money with having to refactor things to make sure that they fit in with their guidelines, and that things aren't just totally messy and all over the place. All right, it says that it has all the context it needs, and it's going to start implementing the code itself. So momentarily what we're going to find is that we have a hook installed that will fire after every edit and new file created if it decides to make any. What that will do is if no issues are found by SonarQube, nothing will surface. It'll just be silent, which is nice. But if there are some issues, it will let Claude know what happened and what it found. Okay, just like right here. The project uses a Java version that doesn't support records, which is what it tried to write with initially in Java 11. So yep, it fixes that from a record into a final class right there. It'll continue making more fixes, and all of this just happens automatically. It's not like reprompting has to happen. SonarQube will find stuff and then feed it back into the agent so that all of this happens without any developer manual intervention. It's going to write some more code, and again, even as it continues to go, it's verifying inline and automatically. All right. So it's finished writing all of its code, and it says all 10 issues are pre-existing. What that means is SonarQube is smart enough to realize that we're not trying to fix everything in one go here. There was a baseline scan done that it's comparing against, and it found that the 10 issues in this file already existed in the baseline scan before we even tried introducing any new code. Why that's important is we're not trying to, go too outside of our scope here. Anything that's new that we introduced, we want to make sure that that's verified, but we have other tools that I'll talk about in an upcoming video, like the remediation agent, which are meant to address existing backlog issues. Yep, we're just going to analyze one last time that there's no multi-file issues. It's running deep analysis, so we're going to make sure that there's no data flow issues happening, which we can catch via taint analysis. All right, so that was kind of a brief overview of some of the capabilities that Sonar Vortex has. I'm not going to go too deep into the woods here about all the different use cases and how things work under the hood, but I just wanted to demonstrate how a real-world coding task might look using this tool. Better guidelines and context in means that there's going to be fewer issues that the agent produces. And then those issues that are created, we verify and we catch them before that code gets pushed out. This is the guide, verify, and solve philosophy that we have in the agent-centric development cycle. We want to guide the agent with good context and rules and architecture and information. We want to verify inline that no issues are being created, and then anytime these are found, we want to remediate these issues as soon as possible and effectively. These coding models are really good, but with SonarQube introduced into the loop, we enhance and improve the quality of our code and the safety of our code going forward.